Hello, hi, and welcome to all my dear students out there. Today we will start with a new chapter, chapter 6, circle. I am very sure that you know many things about a circle. We will just do a quick recap and then start with a property related to chord of the circle. And at last, we will start with the practice set. So let us just recap our information about a circle. I have drawn a very cute circle here. And as soon as you draw a circle or before you draw a circle, actually before you draw a circle, you fix its center. Okay. Normally in maximum cases, we give the center name as O. Point O is the center of the circle. Now, what is this center of the circle? Center of the circle can I take anywhere? For this circle, this center is fixed. Okay, so center of the circle is a fixed point. This point O is a fixed point, and that fixed point is called center of the circle. Okay, so just I'll write the keyword center of circle is a fixed point. Is a fixed point. First thing, this we have to make a note. Now all the set of points which are equidistant from a fixed point. Now this is the fixed point. From this fixed point, any distance if I take from this fixed point, any distance on the circle. Any distance on the circle. If I draw this way or this way, suppose this way, this segment if I draw, if I have taken the radius of circle as 3 centimeter. So on any point here on the circle if you take, suppose I take another segment, this will also be 3 centimeter. Okay, because radii of a circle is same. Anywhere you draw the radius, it will be 3 centimeter. So all these set of points here, set of points if you join, you get a circle. These set of points in a plane which are equidistant from the center, that is fixed point, is called a circle. What I said, let me take a point A and let me take a point B. Like that, there are infinite points. Okay, there are infinite points. So these points, its distance from the fixed point is same or equidistant. Any point you take, that point's distance from the fixed point, that is the center, is the same. So this is called a circle. How will I put it in words? A set of points in a plane. Okay, one point is here, one point is in your book. That will not do. Set of points in a plane, same plane. Set of points in a plane which are equidistant. Kiss say equidistant. These points are at equidistant from whom? From the fixed point. Okay. So a set of points in a plane which are equidistant from a fixed point. From a fixed point, in the bracket you can write what is that fixed point? Center. From fixed point is called a circle. Okay. So once again repeat the definition of a circle. A set of points in a plane which are equidistant from a fixed point is called circle. Okay. So in your 9th standard you should know to define such geometrical figures. In the chapter quadrilaterals, we have learned to define any quadrilateral, that is, let it be a trapezium, parallelogram, rhombus, rectangle, square, all this we have defined. Okay, so what is a circle? Circle is a set of points which are equidistant from a fixed point. That is, that fixed point is center, is called a circle. Okay, so after discussing about the definition of circle, now let us see different parts of the circle. As we know, OA and OB both are radius. Okay, plural radii, R-A-D-I-I, radii. So this fixed point is called as center of the circle. This also you write. First you write the definition, then you write center of circle is a fixed point. Okay. After that you talk about radius. Kya hai radius? Radius is a segment from the center of the circle to a point on the circle. From the center to point anywhere on the circle. सेंटर से होते हुए सर्कल के ऊपर किधर भी एक पॉइंट, दैट सेगमेंट इज कॉल्ड एज रेडियाई और रेडियस. So repeat with me. The segment joining the center of the circle and a point on the circle is called radius. After radius, what do you call as a chord? This radius is a chord? No. रेडियस का एक पॉइंट सर्कल के ऊपर है, दूसरा पॉइंट है सेंटर. whereas what is a chord? Chords both the points should be on the circle. ओके यहाँ पे एक पॉइंट सर्कल के ऊपर है, दूसरा पॉइंट किधर है? सेंटर पे. सो ओ ए इज द रेडियस. व्हाट इज अ chord? Chord is a segment whose both the end points should lie on the circle. Okay, so is this a chord? Is this segment a chord? No. Both the end points should lie on the circle. Then only it is called as a chord. So I will name a chord. Let me take this as chord PQ. This is a chord. Both point P and Q are on the circle. Another chord I'll take. Here I'll take LM. This is also a chord. Now PQ chord is smaller than chord LM. Like that, if I keep on drawing, what will you get? You will get a bada chord, that is this, which is passing through the center. And this chord we name it as diameter. Okay, no, we know this, no? So this is also a diameter as well as a chord. So already I have named here A. So here I'll name it as Z. So what is segment ZA? Segment ZA is a chord as well as diameter. Okay, for this circle we can't draw a chord bigger than this chord. So diameter is called as the biggest chord or the longest chord for a circle. Okay, इसके बाद every chord will be smaller, no, because radius is 3, so diameter will be 3 plus 3, 6. If you come at a lower pace, if you come down, the distance will decrease. So which is the longest chord? The longest chord is the diameter. What is a chord? A segment joining any two points of circle is called a chord. It is a segment which joins any two points on a circle. If you take point here and point there, if you join that segment is called as a chord. Okay, so we have discussed about chord also. Chord. Then center, radius. Now we have discussed about diameter too. Diameter is the longest chord of a circle. So the chord which is passing through the center of the circle, okay, is called diameter of the circle. So I want you to write this definition also. As I say, pause the video and write down the definition or write down what is meant by a chord. As I told you, what is a chord? The segment joining any two points of circle is called as chord. What is a diameter? Diameter. A chord passing through the center of circle. A chord means a segment which joins any two points on the circle. A chord passing through the center of circle is called diameter. Okay, so please write these definitions in your book. These are the basic things about a circle. Now let us discuss the properties of chord. After discussing about what is a chord, what is the name of the longest chord, let us discuss the properties of a chord. The first property is, as you can see in this figure, I have drawn a circle, center is marked, and what is this? Segment which joins any two points on circle, it is a chord. So I'll name this chord as CR. Okay, the chord is CR. This chord के ऊपर there is a perpendicular coming from the center. So from the center we have a perpendicular. Perpendicular means 90 degree. So there is a perpendicular coming from the center. Okay, so as you can see, I have drawn a perpendicular to show that it is perpendicular. 90 degree sign also I showed. Okay, so there is a perpendicular which is coming and which is meeting the chord. As soon as this perpendicular attacks the chord, what will happen to this chord? This chord will be divided into two equal parts. Okay, so the point where the perpendicular is meeting the chord, so this I'll write it as OM. Okay, this point. So OM is the perpendicular. The perpendicular from the, say with me, the perpendicular from the center of the circle to the chord bisects the chord. ये chord को दो equal parts में divide करता है. कौन? This perpendicular. Perpendicular drawn from the center of the circle to the chord bisects the chord. This is the first property of chord, as well as the theorem. Okay, so in this figure, what all things are given? I'll write here. Given circle with center O. Circle with center O. Okay, then we have chord. Chord, what is the name of the chord we took? CR. Okay, then we have a perpendicular. ये भी दिया है ना, the perpendicular who is coming and attacking it. So we will write segment OM perpendicular to chord CR. Chord CR. So this much is given. When this perpendicular comes and attacks the chord gets divided into two equal parts or bisects the chord. This we have to prove. So to prove segment CM is equal to segment MR. We want to prove that CM is equal to MR. So if the whole chord is of 10 centimeter, or here this doesn't look like 10. So if the whole chord is 5 centimeter, how much will be CM or MR? Half of 5, 2.5, 2.5, like that. So we have to prove this. Okay, so very easy proof it is. Write proof. Draw the radii, join OC and OR. They are the radii, no? And radii of the same circle is congruent. Okay, so join OC and OR. Do? Yeah. So what I said, join OC and OR. They both are the radii. So they both will be same length. Now we got two triangles. And which type of triangles are they? They are right angle triangles. We will prove these two triangles congruent. If it is right angle, we will first go for hypotenuse side test. Let us try. ये hypotenuse तो radii है circle का. Okay, and radii of the circle are same. Of the same circle, they are same. So we'll write in triangle OMC and triangle OMR. Angle, first we'll write about 90 degree angle. Angle OMC equal to angle OMR, which is equal to 90 degree each 90 degree angle, or it is given each 90 degree angle. 90 degree angle given also you can write. Okay, first over. Then segment OC congruent to segment OR. Segment OC congruent to segment OR. Reason? What is the reason? Radii of same circle. Radii of same circle. Radii एक circle में radius तो हमेशा same ही होगा. The radius will be same, equal. Okay? So radii of the same circle. So we got 1, 2. Now the third point is OM congruent to OM, because it is the common side. So third, segment OM congruent to segment OM. What will you write? Common side. Common side. Actually, it is common sense also, no? So common side. So we got three things to prove the triangle congruent. We got hypotenuse congruent to hypotenuse. We got this common side and 90 degrees. So this is congruent by hypotenuse side test. Both the triangles are congruent by hypotenuse side test. So last step you will write, therefore triangle OMC congruent to triangle OMR by hypotenuse side test of congruence. Okay, test of congruence. Complete it. So triangles congruent हुआ मतलब we can take CSCT. So CSCT will be CM congruent to MR. Okay, so therefore segment CM congruent to segment MR CSCT. This is what we wanted also to prove, that a perpendicular अगर आ गया chord के ऊपर, the chord will be divided into two equal parts. CM is equal to CR. Last step, please write. Hence proved. Okay, my page ends here. Hence proved. So simple and sweet theorem, and the property also. So say once along with me. The perpendicular from the center of the circle to the chord bisects the chord. You will have practice set related to this property. Okay. So learn the theorem, write it in your book, and we will go for the next theorem now. Let us go on to the next property related to chord. Now this is the ulta of the first property that we learned. In the first property we said that perpendicular from the center to the chord will divide the chord into two equal parts. Now here perpendicular is not given. What is given? If you join center of the circle and the midpoint of a chord. Chord ka midpoint diya hai. Let us take this midpoint of chord as S. The segment joining the center of the circle and the midpoint of the chord, ऐसा कोई segment होगा तो, if there is a segment that joins the center of the circle and the midpoint of the chord, then that segment will be perpendicular to the chord. Just the reverse, no? In the previous property, perpendicular was given. Perpendicular from the center to the chord will divide the chord into two equal parts. That means S will become the midpoint. Now here, midpoint is already given and we have to prove that this OS is perpendicular to chord XY. Okay? So write down given circle with center O. Write down. As I say, you write. Given circle with center O, then you have chord XY, and what extra information you have? S is the midpoint of chord SY. Point S is the midpoint of chord XY. Okay, this is additional information. So what I said, the segment joining the center of circle and midpoint of chord is perpendicular to the chord. Midpoint or center को join करता हुआ segment is perpendicular to chord. So is perpendicular to chord, that we have to prove. So to prove, we want to prove that segment OS is perpendicular to chord XY. Okay. So if you understood what is given and what is to be proved, nobody will stop you from joining the radii like we did before. Take the triangles. Now here 90 degrees is not given. Okay. So we can't prove by hypotenuse side test. So first what you do, join OY and OX. You get two triangles. Try to prove those two triangles congruent and then take CACT. Why CACT? We want to prove it is 90 degree, no? So we will take angle OSY congruent to angle OSX. Now OSY angle is congruent to OSX and both these angles are linear pair. So it will be 180. Like that we will get the proof. Okay, so first now what you do, pause the video and try to prove these two triangles congruent. Then check whether our test of congruence match or not. Okay, so go for it. Yeah, please check whether our steps match. In triangle OSX and triangle OSY, now S is midpoint, no? So I wrote XS is equal to SY. Midpoint is given. So given. Then OS congruent to OS, common side. Okay. Then OX congruent to OY, both are radii of the same circle. So by SSS test of congruence, both the triangles are congruent. Now we will take these two angles and write CACT. So therefore angle OSX congruent to angle OSY CACT. Okay, these two angles are congruent. OSX, OSY, CACT will take. Now OSX and OSY both are linear pair angles. So that property I'll use. Angle OSX plus angle OSY is equal to 180 degree. Linear pair, write the answer. LI, linear pair. So now OSX is equal to OSY. So this you give it as number 1. So from 1 I can write angle OSX plus angle, in place of OSY also I'll write OSX, because both are equal angles, okay, is equal to 180 degree. Now OSX plus OXX will be, OSX plus OSX will be 2 times angle OSX is equal to 180 degree. Bring 2 to the opposite side. So therefore, angle OSX is equal to 180 upon 2. Angle OSX we got 90 degree. Okay, mission accomplished. So see, so we wanted to prove OSX 90 degree. If it is 90 degree, then OS will be perpendicular to segment XY. So write down the last step. Therefore, segment OS perpendicular to chord XY, hence proved. Easy proof for both the properties. Learn both the theorems well, practice it, and then we will meet in the next class with practice set 6.1. Till then, if you have not subscribed to my channel, please subscribe it so that whenever I post a video, you will get the notification quickly and so that you can prepare well. Thank you, children. Please write comments and share it with your friends. Take care till we meet for the next time. Bye.